The Barde Weft senior design team, composed of Matthew Green, Lee Klein, Caleb Sallow, Cesar Valverde, and Josh Martinez, have been working to re examine and maximize performance of the Barde aramid fiber weaving machine. Barde is a company that manufactures and sells aramid fiber weaves for commercial and professional use. These aramid fiber weaves are primarily used in military armors for personnel and vehicles. The weaving machine consists of one machine that injects a strand of fiber called the weft between a crosshatched weave of strands called the warp. The machine is currently limited in speed by the weft scissor. Barde has asked the senior design team to come up with a solution to the scissor to allow for faster cutting speeds. The initial approach to finding a solution for Barde was to spend time with the machine to observe operations and possible oversights. There were very few issues that could be immediately determined by the team, and it was decided to use a high-speed motion capture camera to better observe a failed cut. Even with the slow motion footage, the team only could hypothesize possible areas that could be causing a failure. With a large number of variables present, the team moved to an experimental approach by testing multiple changes and observing the effects. The two primary changes the team focused on was applying blade coatings to the scissor and exchanging the machine's two-phase DC motor for a five-phase AC motor. To improve the blade coatings were applied for testing and increased longevity of the blades, as the current blades are commonly chipped and quickly wear down. Aluminum titanium nitride and diamond-like coating were both applied to blades in various areas. These blades were installed on multiple machines, and employees of Barde recorded all data relevant to each blade's usage over time. This data showed that the aluminum titanium nitride coating caused issues with the performance and did not allow the scissor to complete cuts, while the diamond-like coating cut through all tests and was not worn down even after millions of cuts. Using micrographs, the team was able to closely observe wear patterns, which also showed the coating's ability to increase longevity. The five-phase motor was installed on a benchtop prototype for testing and acquisition of data, as, due to the complexity of the machine control system, the motor could not be installed into the machine in a timely manner. Regardless, the team tested the speed versus torque capabilities of the new motor and proved that the new motor would have increased speed and torque, allowing for faster and more efficient cuts. While power requirements changed with this motor, the increase in power was minimal, while the motor driver allows the control system to use numerous advantages such as motor alarms and speed customizability. The team feels confident in the proposed solutions for Barde that will provide increased longevity, speed, and efficiency.